Well, here we go into part three of bonding. And what have we learned so far about bonding? At least last time, we talked about two major types of bonding. We said there is ionic and that there is covalent. And we said what happens in an in an ionic bond. Sometimes I can talk. Ionic bond. What happens in an ionic bond? Well, that I have an electrostatic force of attraction. There's an attraction between a positive cation and a negative anion, and that creates my bond, the attraction of the positive to the negative, right? And that this cation is usually a metal which has lost an electron, and the anion is a nonmetal which has usually gained at least one electron, and that these guys then end up forming a lattice, right? So that's the general idea of an ionic bond. In a covalent bond, what happens? I usually have two nonmetals sharing electrons. Okay, and when each of these do this, they all gain a noble gas electron configuration. Good. And then we said that, hey, you know what? We could start to predict these guys, and we can predict them using the difference in electronegativity. And we said that the greater the difference in electronegativity, the higher the delta En, the more ionic the bond is. So when I have a number like 1.8 and higher, now remember, this is for a prediction. It doesn't always tell us exactly the case, but if we want to predict, we can look at this. If it's 1.8 and plus, we usually say, hey, it's ionic. If it's 0, we say that this is pure covalent, and that means complete sharing, equal sharing. And if it's in between there, really like from 0.1 to 1.8, we'd say, hey, this is polar covalent. And on the low end of that, we'd say, hey, down here it's slightly polar. And on the high end, we could say it's very polar. These numbers vary a little bit. And remember, the real great idea is understanding that as my electronegativity difference increases, it becomes more and more ionic. Because when I go from 1.7 to 1.8, does it magically go from covalent to ionic? No, it just becomes more and more ionic. Good. So that's a background, what we learned last time. Let's dive into our next consider. Consider lithium plus, so we'd call that the lithium cation. An oxygen 2 minus, we'd call that the oxygen anion, or we'd call it oxide. Draw the electron configuration and Lewis structure for each. Okay, so let's start off with lithium. If we look at lithium on the periodic table, oh, that's another periodic table. There's the periodic table. When you look at lithium, lithium has 3 electrons. Oxygen has 8 electrons. Okay, 3 and 8 electrons. So this is 3, this is 8. So what is my electron configuration for regular lithium? 1s2, 2s1. And my electron configuration for oxygen is what? 1s2, 2s2, 2p what? 4. Good. Cool. Now it says draw the electron configuration for lithium plus. So what is lithium plus? Well, the plus means what? I have lost an electron. Ooh, hey, let's do this a different way. I got a great idea. Let's not draw it this way. Let's look at my noble gas configuration for lithium. We'd say what? This is helium, 2s1. Yeah, I like this better. And oxygen is what? Helium, 2s2, 2p4. There we go. Good. So now let's look at lithium plus. What happens for the plus? That means I have lost an electron. So which electron is lost? How about this one that's in the 2s? So what am I left with when it becomes a lithium plus? It becomes a helium electron configuration. Okay, oxygen. It becomes O2 minus. How does it become 2 minus? It gains 2 electrons, right? If it gains 2 electrons, it is now helium, 2s2, 2p, not 4, 2p, 6. Wow. And what do I really get when I look at helium, 2s2, 2p6? Let's go back and look at our periodic table. Helium, so here's my helium, 2s2, 2p6. What do I have? I really have what? I have a neon electron configuration. So really this now, my O2 minus really is nothing but a neon electron configuration. Notice what's happened. When this guy became +1, what happened? It lost an electron and it has now a noble gas electron configuration. When oxygen gains 2 electrons, it also has a noble gas electron configuration, right? So that means these guys are starting to gain stability by gaining these noble gas configurations. Good, so that's the first thing. Now, next, draw the Lewis structure for each. Okay, we can draw Lewis structures. Remember we said Lewis structures is an illustration of the valence electrons. Good. So Li starts off with 3 valence electrons, right? I think 1 valence electron. 1 valence electron, so what is Li plus? Well, if it's plus, it loses that valence electron, and so we would just say that the Lewis structure for Li plus would be just that. It's Li with a plus, and it's in brackets to let us know that it's a plus. Got it? What about oxygen? Oxygen starts off with 6 valence electrons. 1, 2, 3, 4, 5, 6. Good. Now when it becomes O2 minus, what happens? It's gaining 2 more electrons, so it goes 1, 2, 3, 4, 5, 6, 7, 8. And there we go. I guess I should have my plus outside here. Yoink. How's that? So this is my Lewis structure for the oxide. And notice it has my nonmetal, when it becomes a stable ion, has how many valence electrons? It has 8 valence electrons as an ion. The nonmetal anion, right? And when my metal becomes my stable cation, it shows 0 valence electrons in its Lewis structure. Got it? Okay, moving forward. You guys do magnesium and chlorine. Pause me and bring me back when you have the answers. Okay, here we go. Magnesium. First of all, let's draw normal magnesium. Magnesium has 12 electrons. Chlorine has 17 electrons, right? So magnesium would be what? How about neon? 3s2. So what is a magnesium 2 plus? That means I've lost 2 electrons. Those guys are gone. And so my magnesium becomes just neon. The electron configuration for magnesium 2 plus is a neon electron configuration. Chlorine is what? Neon 3s2, 3p7, right? Oh, I don't think it's 3p7. Maybe 5. 3p5. There we go. 3p5 looks good to me. What happens? It becomes chloride, meaning that negative means it gained an electron. So it becomes neon 3s2, 3p6. And what is 3s2, 3p6 with neon? It has become really what? 3s2, 3p6 looks like it has really become an argon electron configuration. Now, when I say these things, don't confuse electron configuration with the atom. It is still a chlorine atom because it has what? 17 protons. It's just that it now has an argon electron configuration. It has that electron configuration like argon. Got it? Good. And Lewis structure, my magnesium, would look like this, right? Nothing around it, 2 plus. And chlorine, it would have what? 8 valence electrons around it with a -1. So those are my answers to this question. Moving on. Next, consider the ionic compound MgCl2. Describe the process through which it forms. Okay, so we want to talk about the process of forming an ionic bond. Okay, let's start this off and look at the the orbital notation for magnesium and chlorine. Okay, well, I want to start with orbital notation. So magnesium, we just said is what? Neon. So here's magnesium. It has a neon core, and then, like I say, I want us to visualize this well. So we're going to go with a 3s2. Okay, so that's my magnesium. And what's my chlorine? My chlorine is neon 3s2, 3p7. 1, 2, 3, 4, 5. Not 3p7, 3p5. Why do I keep saying that? And we have two of those chlorines. So there's another neon, and it's 3s. Yoink, yoink. 1, 2, 3, 3p. 1, 2, 3, 4, 5. There we go. So here are my chlorines. Now you guys can see what happens, right? Magnesium wants to end up with a noble gas core, right? So what does it want to do? It wants to lose 2 electrons. So it wants to lose this electron, and it wants to lose that electron. Chlorine, on the other hand, wants to have an argon core, right? And what does it need to get an argon core? It needs an electron to come in here, and this chlorine needs an electron to come in here. If each of these chlorines gains 1 electron, then it will have an argon core, which is a noble gas core. So what happens? This electron, or something like that, may end up coming like this and go down like that. And this electron can flip around and go down like that. And now, what do you notice? I have magnesium. Here's my magnesium. It is now a 2 plus. And what's its electron configuration? It has a neon core. My chlorines become chlorides. They have a negative, and it's a neon. Well, it's no longer neon, right? It's no longer neon because it's a neon plus 8 electrons, which makes it that's yikes, makes it an argon core. And here's my chloride and an argon core. And what have we noticed? Both of these atoms, my magnesium and my chlorines, all end up with what? Noble gas electron configurations. Good. Okay, so visually that helps us a little bit. Now let's actually talk about the steps, right? Step number 1. What happens to my metal? My metal does what? The metal, what happened to its electrons? It lost electrons. So my metal loses electrons and becomes a cation. Good. What happens to my nonmetal? My nonmetal loses electrons to achieve. What does it achieve by losing the electrons? A noble gas electron configuration, right? So the metal loses electrons to achieve a noble gas configuration. It becomes a cation. The nonmetal gains electrons to achieve a noble gas electron configuration and becomes what? Whoops, yoy, and becomes an anion. Cool. Now, what happens between the anion and the cation? Hey, I have a negative and a positive. What happens with a negative and a positive? They attract each other. So the anion and the cation attract each other. And when they attract each other, what do they form? and they form a crystal lattice, And that is my story of an ionic bond. Got it? Cool. All right. Did we answer our question? Describe the process. Yeah, I think so. I think we did a fine job of that. Moving forward, consider an atom of sodium and an atom of chlorine. Explain in detail how they might bond. What would the compound look like on the atomic scale? Good. Pause me and answer this and bring me back. All right. What would happen? This is what would happen. Sodium will what? Lose one electron, and when it does that, it and achieves an electron configuration like what? If sodium loses an electron, it becomes like what? Neon. Like neon. Good. Chlorine gains one electron and achieves an electron configuration like, okay, when chlorine gains an electron, it goes from 17 to 18. So that looks like it gains an electron configuration like argon. Good. Now I have what? Sodium plus and the Cl minus attract each other. And form a lattice. Now, how does that lattice look? It looks something like this, right? Na plus, yoink, Na plus, Na plus, na 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 na, na 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 na, na 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 na, na 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 na. Na 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 na. Oops, I lost my key. There we go, and my chlorides fill in here, right? And everybody's happy. Well, no, really, atoms are never happy. They have no feelings. They don't care. There we go. How's that? And they form a crystal lattice. And it looks something like that. Wow, that looks like art. I should sign it. Good. Okay, who wants to buy that for $1 million? Ooh, chemistry art. I bet that's very valuable. Moving on. Okay, so now let's look at my magnesium chloride and draw a Lewis structure to represent this compound. Okay, well, let's start off and let's draw our Lewis structure for magnesium. Right, how many electrons does magnesium have? It has 2 valence electrons because it's in my second column. And each chlorine has 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. You guys remember how I know that? Right? Chlorine is in my 17th column. The halogens, the 17th column has 7 valence electrons. Good. So this is how we start, right? And what do we end up with? Well, one of these electrons from magnesium probably or can eventually or might go like that. And one of these electrons will go like that. Now that doesn't really happen necessarily. Usually magnesium through the nature loses 2 electrons and chlorine gains 1 electron through nature. But this kind of helps us show specifically if I had a pure magnesium atom and a pure chlorine atom, what might happen if they came into contact with each other, right? Okay, so having said all that, what am I left with? I'm now left with magnesium, and it has no valence electrons because it's given them away, and it has a 2 plus. And then what do I have for my chlorines? Well, I have 2 chlorines. Now they're called chlorides. And each of my chlorides have 8 valence electrons and a negative charge. Good. And so this is my Lewis structure to represent what kind of compound is this? Well, it has a metal and a nonmetal, so that is an ionic compound. And so this is the way that I represent ionic compounds, right? Notice, how many valence electrons are shown in my magnesium? 0. It now has a noble gas core. How many valence electrons are shown in my nonmetal? 8. And that's always going to be true in your ionic compound Lewis structure drawings. Got it? Easy. All right, your turn. Pause me and bring me back when you are done. Great. Lithium. Lithium has how many valence electrons? Well, it's in my first column, so that means it has one valence electron. How many lithiums do I have? I have two, so I have to draw two of them. Yoink, yoink. I have one oxygen. How many oxygen valence electrons are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. Now, how can we illustrate what might happen? Well, lithium loses an electron and it might go there, and lithium loses another electron and it might go there. Good. And so what do we end up with? I have a lithium, nothing around it, but now it's lost an electron, so it is a plus charge. I have another lithium. It has given up its valent electron. It has a plus charge. And then I have an oxygen. And how many valence electrons does that oxygen now have? 1, 2, 3, 4, 5, 6, 7, 8. 2 minus. Yay! I'm happy. And that should do it for today. Hope you understand ionic. Ciao.